Hey, Dr. B here, and let's talk about calorimetry and standard enthalpies of formation. These are both commonly used methods for identifying unknowns or finding the amount of heat that a reaction might generate or require. Calorimetry is the measure of heat change, and usually people use a calorimeter, not surprisingly, and this formula to solve various types of problems. The heat generated or required in the system is equal to its mass. More mass would require more heat, for example, or would release more heat, times the specific heat of the substance. Some substances require a lot of energy to change their temperature. Water is one of the biggest, times the change in temperature in degrees Celsius. So the units are joules per gram degrees Celsius for specific heat. Let's solve a problem. Imagine 50 grams of a metal at 115 degrees, so it's very hot, is placed in a fully insulated container. Pretty good. Add water at about room temperature. That water is going to heat up by about 4 degrees or so. We use this table to identify the metal. This problem's a little harder than it looks because, let's see, identify the metal. These are specific heats, C. So I guess C equals Q over M delta T. But right away you run into a problem. We don't know Q for the metal. We've got two unknowns. It's not solvable. So we're going to find the heat that's gained by the water. That we can do because we know the specific heat of the water. Q equals mc delta T. Mass of water, known. There it is. Specific heat of water, I know it. There's the number. Change in temperature of the water. Yeah, a few degrees. We got it. So let's go ahead and do that. And make sure you're always using your water data. I always write these subscripts to avoid confusion. After all, we also have most of these things for the metal. So plug in 125 grams, specific heat of water, got it. Temperature change, got it. Answer, the heat that the water gained is 1900 joules. Now comes that moment of epiphany where you're supposed to realize, hey, all of the heat that the water gained came from the metal. So the Q water should be equal to the Q metal as long as we have a nicely insulated container, which we kind of sort of do. And now we should be able to, we have that Q metal that we didn't have. So let's solve for C metal. So C metal is going to be equal to Q over M delta T. There's our Q. Mass of the metal is given 50 grams. The change in temperature of the metal, now that's, you got to be careful. That's 115 degrees that it started out for. And where did it end? Here or here? Well, this is before you began the experiment. And when the experiment came to its end, it went to there. So 115 minus 29.3. There it is. We get a value of 0.44 joules per gram degree Celsius. You should always get a value of about between 0.1, let's say, and 4 or so. Otherwise, something's probably wrong because all these numbers fall into that range generally. And look, we got a match for something, iron. So this substance may be iron. Wonderful. So specific heat is nice. Calorimetry is a great method to identify unknown substances. Now let's talk about standard enthalpy of formation. This is usually used when you want to see if a reaction is going to require some energy or release some energy. We begin with the idea that the standard heat of formation of any element in its most stable form is 0. And if you're at standard conditions, which we've outlined right here, pressure of 1 atm, this usually is at 298 Kelvin, we can look up some data. Let's find O2. There it is right there. That's its most stable form, so that's 0. But O3 is also just a form of oxygen, is it not? But it's known as ozone. It's not its most stable form, so watch out for that. Graphite, yep, that's its most stable form. Diamond, not so much. Okay, now when you're solving these problems, normally it's pretty easy. The idea is that the overall heat of a reaction, or as written here, the change in the enthalpy under standard conditions of a chemical reaction is just equal to products minus reactants. So find each substance that you need to plug in and plug it in. Do use those coefficients in the chemical reaction. If there's a 2 in front of it, you better multiply by 2. And here it is generically for A plus B turning into C plus D. And plug those in, you'll get a number, and it should give you an idea of if the reaction is exothermic, negative, endothermic, which would be positive, and how much in terms of kilojoules per mole. This is standard enthalpy of formation and calorimetry.